So my name is Hannes. I am a technical evangelist at Microsoft in New Zealand. I flew over from Auckland for the conference. I do a whole range of things, but our team is really focused on working with bleeding edge technology, so all the new stuff, and I help developers to adopt this new technology. Now, I'm not on the HoloLens product group, so if I say anything over here that isn't already public knowledge, and I doubt I will, please don't tweet it, all right? Okay, so I don't have any announcements about when the next HoloLens comes, so please don't ask me about that one either, but they are working on it, and there was a really cool article from Microsoft Research a little while ago about the neural network support that they've got in the new holographic processing unit. So have a look at that one. That's fascinating. So session agenda, we'll do some theory. I've cut this slide deck that we usually use from Corp down from like 40 or 50 slides to 6. So not a lot of theory, and then we're going to jump in and do some development and see how I built a little paddle bounce app. It's not a great app, but it gets a point across. And it's on the App Store, so you can go have a play with it. So the first thing that I just wanted to do is I want to just talk about this mixed reality term, because it's something that's kind of evolved a little bit over the years, and I find that right now there's a lot of confusion about what does mixed reality mean. And a lot of it is because you heard a lot of different messages from Microsoft about it. We've evolved this term. So at one point we used it to refer to the HoloLens as the only mixed reality device, and then we used it to refer to our new upcoming Windows 10 immersive headsets. So we called them mixed reality headsets, but not HoloLens. And now the current iteration of it is really this. There's this virtuality continuum with AR on one side and VR on the other side, and it's all about how much of the real world bleeds through. And we use the term mixed reality to refer to the whole continuum. What makes these mixed reality devices? It's their awareness of the world outside. Now, the new upcoming devices, they have cameras that they use for tracking inside the device itself. So unlike the Vive and the Rift, you don't need to set up a whole bunch of other cameras. We call this inside-out tracking. So that awareness of the world that allows it to do that tracking without the external cameras, that's what makes them mixed reality devices. And the same goes for the HoloLens. Okay. The HoloLens itself is this device over here. It is a fully untethered computer. It's got Wi-Fi, Bluetooth, so its own internet. It runs a special build of Windows 10, and you can put it on and you can go outside. Well, don't go outside with it, but you can go away to building sites or whatever and use it as an offline device. It doesn't need internet connectivity. It doesn't need to be tethered to your phone or to your laptop or any of that. It's a standalone device. You install your apps on it. It's got, I think, about 120 gigs or 60, I think about 120 gigs of space on it. So you can install a lot of apps, download all of your content, and then go use it where you don't have internet, which makes it a pretty special device. Now, we'll look at some of the details of what you can do with it in your app as it comes across. I believe Lars have already covered off a lot of what the device is and what you can do with it and that stuff. Stephen spoke about it earlier in the week as well, so I'm not going to bore you all with that again. It's been around for almost 3 years now, 2 years in the public eye, so there's a lot of content about the device itself. What we're going to talk about is developing for it, developing for Windows Mixed Reality. Now, anyone can buy this device. It's a little bit expensive, but you can buy it. You just go to the Microsoft Store and put in your credit card, and they'll ship you one. So it is accessible. It's not a private thing. You don't need an invitation code from some obscure guy in a back alley. Developing for Windows Mixed Reality. So it's a Windows 10 device. I already mentioned that, which means that you build UWP or Universal Windows Platform apps for it. Those are the same apps that run on Xbox and tablets and Surface Hub and mobile phones. This is probably one of the last ones in Australia, but they're still around. So Windows 10 apps, you write the app once, it'll run everywhere, but there is special extension SDKs that gives you access to those special device features. So that in itself is an hour-long discussion. So what tools do you use to develop for HoloLens? You use Visual Studio to build your Windows app, and it's really just DirectX that you use to render the images to the display. Now, anyone who's ever tried to build a game, and like most other middle-aged white males in the IT industry, I did once harbor this illusion that one day I'll be a game developer when I was young, and then I tried to write some C++ code with DirectX, and I figured out that you spend 99% of your time developing a game engine and 1% of your time actually developing a game, right? So The world has moved on. We've now got middleware like Unity. Unity is a outstanding game editor, and just less than 50% of the world's mobile apps, mobile games are actually written with Unity in the app stores. So it's widespread use, big community, it's been around for a while, it's stable. There's an asset store for Unity where you can get all the 3D assets and stuff that you need. And so Unity is my recommended way of building HoloLens apps. About over 90% of the apps in the store at the moment for HoloLens is built with Unity. And we use that to build solutions for our customers through our services division as well. Now, there's a whole bunch of stuff that we've gotten out of those apps that we've built for customers that's reusable components. And we put those into the Mixed Reality Toolkit, which is an open source thing on GitHub. You can go get those components out, you can use them in your app, you can contribute fixes and contributions back to it. It's also known as the HoloToolkit. We're busy renaming it now from HoloToolkit to Mixed Reality. Everything that was Holo is becoming Mixed Reality. And that is to acknowledge the fact that you'll use the same toolkit, the same APIs to also target the upcoming immersive headsets, so those VR headsets. There's really only 3 new APIs to support those. Everything else is the same stuff as what we built for HoloLens. So again, it makes it really easy for you to write an app that'll work everywhere. Let me just talk one more thing about that. So this is the basic structure of an app that you'll build. You'll use the Windows APIs that takes care of things like where's the device pointing, what are you doing with your hands, with the gestures. Then you'll use the open source Mixed Reality Toolkit to help you do things a little bit easier. They've got a whole bunch of prefabs in there that does things like event management, and I'll show you all those kind of things. And then you've got the app experience that you build. So that's your 3D models and your textures and your scripts that kind of tie it all together. So, without further ado, that's the end of our theory session, and now we'll jump into our development, right? So, where do we get the mixed reality? Actually, no, let me first jump into Unity. So when you go open up Unity, you get a little window like this, and you go File, New Project. Now, in the interest of time, I have already done that, but this is important. Check out the version. With Unity, it's really important to be aware of what version you're using, because they bundle the editor and the runtime together. And so when you upgrade the editor, it also upgrades the runtime. And there's often breaking changes that'll break your stuff. So you don't just arbitrarily update Unity. That you can install them side by side as well, so you can have several different versions. But you want to be careful of that one. It's bitten me a couple of times. So when you go File, New Project, this is what you end up with. This is mostly an empty Unity project. What I've done over here is I've just pulled in some pre-built assets so that we can get started a bit quicker. The first one that I did is the HoloToolkit, right? So where do we get the HoloToolkit? Well, we can go to GitHub. That's the GitHub site for it over here. And we can get it from here. So they're working really hard to improve the documentation, but the documentation is still not great. You go to Releases, and then in this little page over here, you'll see every time that we do a release from the master branch, we'll put it in here. And we are now matching these releases in the master branch to updates to the Unity editor, right? So again, that version number is important. You need a particular version of the toolkit to support a particular version of Unity. You always want to match them up. Otherwise, you get weird stuff happening. Okay, so we've downloaded the Mixed Reality Toolkit, and we go Assets, we go Import, oops, not Export. Assets, Import Package, and Custom Package. And then we go find the place where we downloaded it. And that's this guy over here. That's what it looks like. Once you click Open, it'll take that package, it'll extract all of the things out of it, and it'll create a folder in your Assets folder for it called HoloToolkit. We're renaming it to the Mixed Reality Toolkit in the next version, but this one is still the HoloToolkit. So this has a whole bunch of folders in them again, and each folder has a bunch of stuff in them, like these prefabs over here. Now, if we go have a look on our hard drive, this is the contents of our Unity project, this guy over here. Okay? And in the assets folder, that's the stuff that I just showed you down there in what we call the project view. Okay? So everything in your Unity project is just files. There's a little meta file that describe all the properties of the the asset that you've pulled in, that you change in the editor, but it means that it's really easy to put these things in source control and work like a civilized developer when you share the workload. Okay, so that's very cool. So we've got the HoloToolkit brought in. I've got 2 other folders here. This ADG textures one. This is something I got from the asset store. I'll talk a little bit more about that later. And then this folder over here is my project's asset folder. Always create your own assets folder so that you can keep your stuff together. So you'll have a whole bunch of third-party toolkit stuff over the year in this view, and then your folder with your stuff. Now I've pre-built a few things here, just again to speed us up. But before we go on, I just want to show you what we're actually going to build. So I've got this tiny little video over here, paddle bounce demo. This is a build of my app from a little while ago that I recorded for something. And it's very simple. There's a little paddle. We look at the paddle, we tap and hold, and then we can move the paddle around and bounce it up and down. And there's a little ball up here in the air. So when we grab the paddle, the ball gets gravity, it falls. We bounce it on our paddle, it falls on the floor and rolls around. When we let go of the paddle, the ball comes back to where it started. I've got a few other things over here like that scoreboard over there, and I'm kind of still working on the app. What I'm also doing is writing a tutorial series in which I'll go into a lot of detail about how I'm building these apps and explain all of these things. So that's also on my GitHub repo. I'm open sourcing it, so you can fix my typos if you want, or make contributions, or just use it and go through it. I'll see how much interest there is in it whether I actually finish it. But yeah, I've already kind of written the first 3 parts, and we started with how to install the tools. And yeah, okay. So now that we know what we want to build, let's start building it. So once you've got your toolkit in, the next thing you need to do is you need to add a camera to your scene. Okay. So in the HoloToolkit, we've got some prefabs. A prefab is a collection of things that's just kind of built for you, and you can reuse them. So you just drag them into your scene. So that's what we're going to do here. Over here on the left, this is our hierarchy view. You can think of it kind of as the DOM for your web page, right? Is that place where you've got all of the things in your web page? Well, this is where we've got all the things that's in our 3D environment, in our 3D world, okay? So we need a camera, because the camera is what is used to determine how to render things, okay? So that provides it with the display, basically. Now, I'm using a pre-configured HoloLens camera over here. You don't have to do that. You can use a regular camera, and then this HoloToolkit menu item, this comes with the SDK, with the HoloToolkit package that I imported. So again, that's why it's important to maintain the versions, all right? So it's got really deep integration into the editor. So if we go over here into configure and apply HoloLens settings, there's a bunch of settings over here that'll apply to your camera for you to help you get started. I'll just quickly take you through what those are. So some of the main differences is this background over here. So typically in a 3D game, you'll put up a skybox. Over here we can see in our game preview, the skybox they have has brown land and a sky over there. For a HoloLens app, we want to set the skybox to just be a black solid color. And the reason for that is that the display is an additive light display, a light engine. So it projects light into your eyes. So when it projects black, that's really the absence of light, and you get a transparent effect. So as long as your skybox is black, you can see through the lenses and see the world around you. If you make the skybox blue, then you get this blue kind of that obscures the world in front of you. There's times when you want to do that, but this is not one of them. The other thing that it does is we set the field of view so that it matches the field of view of the device itself, and we're not rendering things that we can't display. And then we also set the clipping planes. Now, the clipping planes is how close and how far it'll keep on rendering. If you render things too close to a user, it actually gets quite uncomfortable. So you want to kind of cut it off. The default is 80 centimeters from you. For this game, we'll just bring that a little bit closer because we're kind of working with something in front of us over here. So that's our camera. Now, the next part that we need over here is actually our ball. So I'll pull in, actually, let me show you how I created the ball in the first place. I went right-click, game object, 3D object, and I added a sphere to my scene. Right? So there's a few kind of 3D things that you can add. This here is the sphere. I'm just going to pull this one out and pull in my prefab ball. And then I'll also pull in a prefab for my paddle. Okay, so that's what my paddle. That's what my paddle looks like over there. We can go around it with this little gizmo over here. Very cool. So how did I build this paddle? Whoops. How did I build a paddle? I went right-click, I added another game object, a 3D object, and I used the cylinder type. So a cylinder looks like that. And then I squashed it down and made it a bit smaller. Then for the handle, I added another game object as a child to the cylinder called a capsule. And a capsule looks like a pill box, right? Let me just pull that out so you can see. That's what a capsule looks like. I took that capsule, I rotated it onto its side, and I made it a lot smaller than it is. So I'm going to delete these two and just take you through the modifications I've done. So there's our ball. Now the ball is located at 001. Our camera is at 000. So that's the origin of our scene. Right in the middle of our scene is our camera, and that's our head. That's where our head is, where the HoloLens sits. Now the ball is at 001. So this x-axis is left to right for us, y is up and down, and z is closer and further. So this ball is located 1 meter in front of us. I am very, very happy that for once the Americans didn't get to decide which units we're using, so we're using meters like civilized mathematicians do around the world. The paddle itself is located 30 centimeters down from the center and a meter out, so just below our ball, okay? And then if we look at the scale function over there, our ball is 4 centimeters across, so it's about this big. I tried it with a standard paddle, ping pong ball size, and it was just a little bit too small. It didn't work that well, so 40 centimeters it is. Our paddle is 15 centimeters across and 16 centimeters deep and half a centimeter high, okay? Now, here's an interesting one. The handle itself, if we look at the handle, you'll see the numbers over here don't make sense, okay? Z4, nothing there is 4 meters, right? So the reason for that is because it's a child of the blade, of the paddle, all those values are relative to its parent, okay? So it is 20% of the width of the parent. So in my tutorial I made the calculation, but my maths is not strong, so I'm not going to do it now. It's half the depth of our paddle, and it's 4 times the thickness of our paddle. Now that's strange as well, right? Because y I said was up and down, and now it's this, and that's because we've rotated around our x-axis. So that swaps around the y and the z-axis. So you kind of figure these things out as you play with it. Sometimes you're just changing the values over here on the right-hand side, and just to see in the preview what's actually changing. And then, oh, okay, so that's the wrong one, so I'll try that one. And it's kind of, yeah, you get used to it. Okay, so now we've got a ball and we've got a paddle. That's kind of already a part of our game. Now I want to show you on this camera. If we align our view with the camera itself, align view to selected. This block over here, that's what the camera can see. See how it matches the camera preview over there? Now if we go like that, see this full stream? So that gives you a really good idea of what's in your camera view and what's not. Now we can preview our game, and this is a really important part over here. You want to be able to run your whole HoloLens app in here, because deploying it to your device takes time and effort, and you are going to take weeks to do even a simple app if that's what you're going to do all the time, right? So you want to be able to run as much of it in your editor as you can. And you would be amazed how much you can run in this editor. So if we just move back from our scene a little bit, this is one of the other cool things of the HoloLens camera is it's got this gaze controls object over here. And what this lets you do is control the camera with your mouse and keyboard and a gamepad. So again, you want to be able to simulate everything, because otherwise you would have to put the HoloLens on and walk around and see what things are like. You don't want to do that. You don't want to do that. You want to be able to simulate all of that stuff. So we can see our ball and our paddle. Now the next thing we do is we're going to enable gravity for this ball. So there's a few things over here. There's this sphere collider object, actually, let me first talk about the rigid body. So what is a rigid body? What is this whole panel, actually? So these components over here is what gives the game objects functionality, which lets them participate in our app. So we've got a game object, and each game object can have a whole bunch of different components. And you can have multiple of the same components on there, and you can have different kinds of components, but they're just little isolated pieces of functionality. So one of the base ones is the transform component that we've already looked at. Another one is the rigid body. A rigid body is what gives your object mass, which makes it kind of participate in the physics. So with this rigid body on the ball, we've set that our ball is 27 grams, which is the weight of a ping pong ball. It's got no drag at all, and we can enable gravity on it. Now, if we click this button, suddenly our ball starts falling, right? Did you guys see that? Let's do that again. This time, I'm going to not show you in the game view, but in the scene view. And we'll pick our ball, we'll click the gravity button, and it falls, right? And it falls, and it lands on the paddle, and it just kind of stays there. Now, how does that work? There's another thing over here called a collider. If we look at our paddle, we'll see it's also got a rigid body on it. And both of these have colliders. Now, what the collider does is that's a Unity component that raises events when two objects start touching each other. Okay? So it raises an event, and then the physics engine knows, okay, it's touching something else. Now I need to see what is it touching, what's the physics that needs to happen over here, and in this case, it's just going to stop. Now, that's not particularly useful for a game called Paddle Bounce, right? It needs to actually bounce. So we need to tell this collider what needs to happen when a collision occurs. And we do that with something called a physics material. So in our little project place over here, we'll go ahead and we'll go right-click, create, and we'll create a new physics material. Usually you'll use a different one for each kind of object, depending on what it's made from. In this case, I'll just use the same one. I'll call it PB Physic, because that is a really cool name for things. Now, on this physics material, I can set a few values. We're going to set the friction to 0.1. It goes from 0 to 1, and the bounciness to 1. Now, dynamic friction is used to calculate how much energy is lost when two things hit each other. Static friction is used to calculate how much energy is lost when they rub against each other or roll over each other. Okay? Bounciness is how much energy is retained when it collides away. If we make it 1, no energy is lost. If we make it 0, all energy is lost. So we'll just make this 0.9, so it's nice and bouncy. And then we'll assign that to these two objects over here. So we'll drop that into our collider's physics place. We'll do the same for this guy over here. Cool. Now, if we preview our app, do that, and enable gravity, see it bounces. How awesome is that? Do you know how much code we have not written? Right? If you tried to do this 10 years ago with C++ and DirectX, and you wrote your code, even if you had good tools, just getting here was weeks and weeks, because you would have to go build a physics engine. And a few years ago, still, you would have to pay large amounts of money to be able to use this kind of an engine. If you think about things like the Frostbite engine and Unreal engine, and even then you'd still have to spend a week or so just writing the code to make that engine do this. We've done this in 20 minutes. So I think that's pretty cool. That's why we use Unity. So let's stop our app. Now, the next thing we want to do is we want to be able to move our paddle around, right? So to do that, we need a few things from the HoloToolkit. The first thing that we need is an event system. And I'm going to get the input manager prefab. That guy over here, and I'm just going to pull that in. And now let's look at this. This is just, this doesn't have a rigid body, so it's not an actual object that is in our view that participates in physics. This is a collection of scripts. So it's got this gaze manager script. What that gaze manager does is it determines what you're looking at and how to interact with the things that you're looking at. It'll pass events through to them and do other really cool things that involve some maths that I don't know how to write. So it's also got a gaze stabilizer. That's really important because your head is actually quite jittery. You don't notice it because your brain is really good at compensating for it. But as soon as you start trying to do maths with that stuff, all that jitter and noise comes through. And when you're looking at an object on the other side of the room, what is really imperceptible jitter over here is it like jumps like this in that straight line. which is why it's so hard to send things to Mars, because that's very far away. So if you're just a little bit off over here, you end up sending it to Uranus instead of Mars. So that's the input manager. It does something else for us that's really cool. It's got this editor hands input thing over here. So now if I go play, again, we want to be able to simulate everything in our editor. So now I can control my hand. I hold shift and my mouse controls my hand. And if I click, that's like doing that air tap gesture, right? So we've got down and up. Okay, so that's really, really useful again for being able to write our HoloLens app. Spacebar does our right hand. And you can see over there in this inspector panel how that stuff changes as we do. So you get that live feedback and the way that we did the gravity. So that's useful. We also would like to have a cursor. Now in the HoloToolkit, again, we provide you with a few different cursors, a basic cursor, a cursor, cursor, cursor. I like this interactive mesh cursor because this one kind of looks like the one that we use in the shell. So now if we play again, see that little donut shape and how it hugs the object that it hits? I think that's pretty cool. The other thing it does is when it sees your hand, it grows, and when it detects a tap, it goes into a dot. So this is really important for users because the gesture box where we recognize gestures is around here. So you always get users who start trying to do this, or they'll look there, and it's not picking up their hand, and they don't know it. So you want to provide this kind of feedback that says, hey, I can see your hand. I can see you tapping. I can see something happen. So always provide that kind of feedback. It's kind of like having a mouse over effect on your web page and having a click effect on your button. You want to do that kind of stuff. Okay, so we've got a cursor. We've got an input system. Now let's see how we can make that paddle be able to be dragged around. So there's another script in the toolkit called the hand draggable script. And we'll drop this on the paddle. So what we did right here is we added another component to our game object. Again, it's this script over here. So it's got a few properties that we can play with. I want to play with this distance scale. I want to make that 1. What this one does is it translates the movement of your hand to the movement of the object. So if that is 2 and I move my hand 1 centimeter, the object will move 2 centimeter in that direction. If you are trying to move things around on the other side of the room, that's really useful because you want to move it large distances without having to go walk around like this, right? That's not a good experience because people get tired, and tired people don't like to use your app. In this case, we want it to be really accurate, so do it at 1. In some cases, you want to go below 1 because you want to be able to really finely be able to pick things up. So you want to play with that one, and again, you can do that programmatically as well to use different things for different scenarios. So we've dropped our script on here. We're also going to set the rotation mode so that when we move this paddle around, it'll always orient towards us. So the handle will always point at us, and we're going to keep the keep upright option so that it stays flat like that. Otherwise, it starts tilting, and it's really hard to hit the ball a second time if your paddle is tilted like this and it kind of bounces off to there. Okay, so we'll keep that option on over there. Done. Now, let's see how well this works. So I'm just going to stand back a little bit over here. So we can move our paddle. Oops, can we? We can move our paddle around, right? See, how cool is that? Okay. Last thing we need to do before we've got a minimum viable product is we need to make the ball actually fall when we grab our paddle. And this is now the time when we whip out our elite coding skills. And we say create a new C# script. We'll call this one paddle behavior. So up till now, we've really just used the HoloToolkit stuff, but now we actually start to need contributing to the cause over here. So we've got this paddle behavior script. By default, that's what Unity creates for us when we say create a new C# script. And we're going to drag this onto our paddle. And now if we scroll down over here, we'll see there it is down there. Paddle behavior, and it'll highlight it for us when we click there. If we double click it, it'll open it up for us in Visual Studio. So Visual Studio says that the project has changed. Now I've already opened this up, but Unity will open it up for you, and it'll connect Visual Studio up with what you're looking at. So now this is our Visual Studio project for this app. You'll see that there's 2 projects over here. This one is where all of our scripts are. We expand that, we see assets, HoloToolkit, so all of the HoloToolkit scripts are in there. And the paddle bounce Script, our script is over here. This is the one that we just created. Okay, so I'm just going to delete that stuff. We'll get back to that. All of these scripts all inherit from mono behavior. It's just how the engine knows what to do with this script and how to do things on it. So to tie into our HoloToolkit, into that event system that I spoke about from the input manager, we're going to implement an interface called iInputHandler. Cool. So iInputHandler is something that comes out of the HoloToolkit. So if we go control dot, we get this handy suggestion to pull in holotoolkit.unity.input module, and then we need to implement the interface, and it's got two methods on it called onInputDown and onInputUp. So remember that gaze manager that I talked about a little bit earlier. So whenever you're looking at something and you do this, the gaze manager and the input manager will go have a look, what are you looking at? Take that game object, run through all of the components in that game object and its children, so that game object tree, and see if any of them implement any of the interfaces that we're interested in. Now, the one interface that we're using over here, iInputHandler, this one has onInputDown, which will be called whenever you do this. It's got onInputUp, which will be called when you do that. Now, why is that not called onFingerDown and onFingerUp? The reason for that is because you use the same interface if you're using the motion controllers or the little Bluetooth thingamajig, Bluetooth remote. Let me show it to you. So you get this one with every HoloLens that you buy. I use this one for the older executive people at companies that I show HoloLens to, because they really struggle to learn how to air tap. So if they don't get it in a minute, I give them one of these, and it's like, okay, let's just move on, and we'll see what you can do with the device. So, yeah, so onInputDown, it also works for the triggers on your motion controllers. So again, it's the mixed reality toolkit, not the HoloLens toolkit. Okay, so this is useful. So onInputDown, we want to add gravity to our ball. So we need a ball. We need a reference to the ball. So how do we do that? Well, we can go find it programmatically out of the scene, or we can create a public field of type rigid body, and we'll call that ball. Okay. Now, I used rigid body over here because I only want objects that have a rigid body component on them to be assignable to this field. If I used game object over there, I would get any game object. Now, if we look at our script over here, it's compiling, and there's our ball field. So now we can go and click that button, and it'll show us all of the things in our scene that's got a rigid body on it. And we're interested in the ball. Notice the camera isn't there because the camera doesn't have a rigid body. The input manager doesn't have a rigid body. So you want to use that, be specific about that, and make your own life a lot easier. Okay, so we've assigned a ball. We've got a reference to our ball now. Now what we want to do is we want to say ball.useGravity as true. Okay, we'll save that one. I want to show you something really cool over here. Is I can attach this to Unity. Okay. So it starts a build off. It builds our project and the Unity editor. Okay, it's attached now. So now if I go back to Unity, come on. Now if I go back to Unity and I wait for it to finish compiling over here and I click play, I can go down to my scene preview, tap on it, and we hit our breakpoint. Right? So we can step through the code running in the Unity editor. So again, you want to be able to do as much dev in there as you can, and you can do quite a lot. So we can do things like inspect our variables, ball, this use gravity one, we can pin that one over there, move it out of the way, step through our code with F10, see how it changes the value of our variable. Very cool, I think. That's why we like Visual Studio. No more console.println, right? Like in the old days. Yeah, and so now when we tap our paddle, the ball drops. Okay, so we're kind of halfway there. So now we want to return the ball back to its original place when we let go of the paddle. So that's something that we will do in onInputUp. So we'll go ball.transform.set position and rotation, and we'll use a regional position for that and a regional rotation. I contemplated recording this typing experience, but I just couldn't get myself to do it. So we declare our fields. Again, Visual Studio is getting much better at writing our code for us. ReSharper is still the king of that. It took me a long time to learn how to code without ReSharper. So on input up, we'll set the position of our ball back to the original place. But now we need to know where it comes from, right? These fields are undeclared at the moment. So remember those messages, those methods that we deleted right at the beginning? We're going to have to pull them back in. So we can go in Visual Studio and say implement Unity messages. And this is the list of those standard messages. Now, in Unity's messaging system, as the app runs, it'll go ahead and call all of these methods if they're implemented on the game objects or on the components. So the one particular message that we're interested in now is start. And we'll select that one and we'll click OK. And this message or method gets called whenever your script starts up. When the game loop starts and everything is set up, it'll call this one. And you can do startup logic over here. There's another one called update. That'll be called on every frame render. So every time that you're rendering a frame, it'll call update, and you can change what's happening in your app. So that gets called 60 times a second or more or less, depending on how good your code is. So in the start one, we want to assign those fields. So we'll just say original position equals ball.transform.position. And we'll go original rotation equals ball.transform.rotation. Cool. So now we know where our ball starts at the beginning of the game, and we can put it back there when we're done. So just wait for it to finish compiling down there. Okay, and we run our game. Just going to step back a little bit. And now if we tap, it'll bounce, we let go, and we go. Okay, so there's one more bug in there, in that we have forgotten to disable gravity. Okay, so there's two more things we need to do here. One is ball.useGravity equals false. And there's another thing called isKinematic. Did I explain what isKinematic does on the rigid body? Okay, so what happens with this isKinematic feature let me just disable it again. And we'll go back to the Unity tool, to the Unity editor. On my ball, I've got this disabled. So that means that the physics engine will control where the ball goes. It'll control its position. On my paddle, I've got it enabled. isKinematic is enabled because we programmatically control the position of the paddle. So it's not controlled by the physics engine. Now, if you don't switch it off on that ball, when you move the ball from here to there and that value is still on, the physics engine picks up that you've applied a force to the ball to get it from here to there, and it continues applying the force or not. It's kind of unpredictable at that point. And the ball often will end up drifting just off into the ether because it's got no gravity. So that's not really ideal, because then you've got to run after the ball with your little paddle, and it's not a good game. Okay? So now our ball will go back to where it came from, and we'll disable the gravity on it, and it'll go stand still again. So now it's time to see how that runs on the actual HoloLens device. So the first thing I'm going to do is I'm going to enable the mobile hotspot on my computer so that I can connect to it from the HoloLens, which have probably gone to sleep now. Turn that on. Okay, cool. So while that's going, let's see what we do from here. We go File, Build Settings, and what we're going to do now is build a player. Okay, we're going to build a UWP player. Now you see this is a very long list over here of things. Now previously I showed you that game editor runtime over there. That's how we're running the game at the moment. But if we want to run it as a UWP app, we're going to need a different version of that built for UWP. So that's what we're doing here. So when we do that build, click the build button, it'll now take our game logic, so that first little project. It'll take all the assets in our assets folder, like the models and stuff, put that stuff in a bundle, compress it, put it together with our scripts, and then grab the UWP editor or the UWP runtime from its installation directory, and to put these three components together and create a Visual Studio solution that contains all of it. Okay, so now it outputs a UWP app that we open up in Visual Studio, and we go on with that. If we build an Android app, it'll create you a project with an Android runtime that you open up in Android Studio. If it's an iOS project, you'll open it up in Xcode. Okay, so we go into this builds directory. It's not this solution. That's the one that we've already got open. Double-click it, and it's this solution over here. Now, let me just see if I opened it before. I think I did. It's this guy over here. So it says that it detected that the solution were modified. So it'll just want to reload that for a moment. And here we go. So that's our UWP app. So this project over here, that's our scripts that we had. Now I checked the box to include the scripts, don't pre-compile them, which means that I can go ahead and debug these scripts right here from the from the Visual Studio project. So that's really cool if I want to debug against my HoloLens device. So previously we debugged against the Unity editor, now I can debug against the device. Now to run this app, we simply go and we need to change this. We should change this to release. If you put it on debug, you can debug. Release is a bit faster. Debug has quite a lot of instrumentation in that drops your frame rate. Frame rates are really important. And then master is for when you build the package that you want to put over to the store. That'll enable the .NET Native toolchain that you need to build all UWP apps for the store. So we'll keep that on release. We'll use the x86 architecture because this device has an Atom processor in it. And we'll push it to our device. Now we've got some options over here. We can push it to the HoloLens emulator. That's a separate install, again a free download. It uses Hyper-V, so you have to have a version of Windows that can run Hyper-V. And that'll start it up for you and deploy it to your HoloLens emulator. Or you can use the remote machine option. I'm just going to use device for now. Device is whatever device is plugged into my computer with a USB cable. Okay, if I use remote machine, I can use the IP address of this device and push to it over Wi-Fi. So I don't need to have it plugged in. I can push to it through Wi-Fi, which is pretty cool. So right now Visual Studio is building our solution. And then I've got this HoloLens app over here that I can use to connect to the HoloLens. And if I click that button, it'll show us a live stream from the device. And we can see over there that the deploy has started to our device. So it's copying the files over and installing my app, doing all that kind of stuff. This is a good time to have some elevator music. Okay, so it's almost there. It goes a bit slower when you've got the live stream going. It's faster when you don't. Now it's installing the app. Deploy succeeded, so now it'll launch the app and connect to it. Cool, and now it's connected, so now it's getting telemetry back from the app, and the app is actually starting to start up. And so now you'll see the Unity splash screen. That's because I'm using the free version of Unity. If you want to get rid of the splash screen, you need to pay them some money. Get the pro version. Otherwise, the features are more or less the same. Also, the Visual Studio version that I'm using is Enterprise, but it works. You can use Community, which is the free version. It has pretty much the same features as Pro. So you don't need to buy a whole bunch of software to do this stuff. You can use the free versions for everything. The only thing you need to buy is a headset. But you can use the free emulator if you still need to make the case to your boss. Okay, so here's the ball. Here's our paddle. We can see it kind of nice and stable. Okay, and if I tap and hold, my ball starts jumping, and I drop it, and it's fallen off into the ether, right? Cool. It's an MVP, but it's not something that anyone is going to pay us money for at this point. So let's stop that one. So, okay, how do we add a little bit of flair to our app? Let's put this one off to the side again, and we'll look at some of the other features. We're going to go right up to 10 o'clock, so be prepared, another 15 minutes. We'll close this one down. So the first thing that we want to do is we want to add spatial mapping so that our ball doesn't fall off and run off into the ether, right? How do we do that? Do we spend months writing code to do that, or do we go spatial mapping manager? We pull that guy in over here, and we have a look over here. So it's got a few useful things in there. These two components, the observer and the manager, takes care of taking the device data, the 3D model that the device is building of the room that we're in, and bringing it into our app and making it accessible to us to interact with. This one over here is, again, something that's really, really useful for the editor, and it allows us to take a 3D model, like this guy over here, this room model, and load it into our editor. Now, where do you get those models from? It took me ages to figure that one out. The documentation isn't particularly clear on it. You go into your HoloLens' developer portal. There's a little website that runs on it that you can connect to that allows you developer access to the device. And in there, there's a place where you can see a real-time 3D map of what it's generated, and you can save that model down. That's an OBJ file that it saves, and that's the model that you pull in over here. If you're using the emulator has that exact same device page. They've got a few models set up in the emulator already. So bedroom, this is where I actually got this one. You download them, you set this emulator up to use that model, then you go into its devices portal and you just download the model that it's gotten. So now, if we look over here, I've got draw visual meshes switch on. So if I press play, we'll now see a mesh of the room that we're in. Now it's kind of hard to figure out what this is, but there's like a chair over here and a bed and some other stuff. If we jump out to, where's our paddle gone? The paddle's missing. Anyway, if we jump out to the scene view, you can now see that over there, and then let me just restart it. So I want to grab this paddle, but this part is a little bit hard. So now if I go and grab my paddle, and oops. See, we missed it. Okay, the ball was kind of rolling around over there on the floor, and now it's gone again. I'm not going to spend more time on that. So it's there. It knows the floor. It knows the environment that we're in now. So that's pretty cool. Now, the other thing, I talked about sound earlier. Sound is really, really important. So we're going to go, and on our ball, we wanted to make a little ping pong ball sound. So this is a little MP3 that I got off the internet. I can click play over here, and that's what it sounds like. So we want that sound to play every time that the ball bounces on something, right? So to do that, we'll go and first of all, go to our player settings, or project settings, audio, and we'll enable a spatializer plugin. So we'll use this one over there. That one's for when you're doing Oculus work. We'll use the Microsoft one. And what that plugin does is it translates a 3D space, a position in 3D space, to how much volume to play on each ear, so that if something happens on the right, I hear it on the right. If it happens on the left, I hear it on the left. Closer sounds are louder, further sounds are softer, so it takes care of that for us. On our ball, we will add a audio source, and we will assign that audio clip to it, ping pong ball. Now that's a mono clip. That clip is just one channel, but we hear it in stereo based on where the thing is, thanks to that spatializer plugin and this checkbox over here. So this checkbox tells it to pass the 3D data along with the clip to the plugin and the audio system. Okay, so now we've got a sound attached to our ball. If we press play, it'll play the sound once, and it'll stop. Not quite what we want. So we go over here again, and we disable play on awake. So don't play it when the component wakes up. And then we return down here to do some more lead hacking. Okay, so we create another behavior. We'll call this one ball behavior. Hit enter. This detected there was a change, so reload, and here's our ball behavior. Sometimes you have to just reload that project manually. Like sometimes it doesn't pick up the new file. So on this one, we're going to use one of those standard Unity messages again. So implement Unity messages. And we will use on collision enter. All right, see, so there's a number of different messages there. There's about 65. We'll use that one over there, on collision enter. And this one will be called every time that a game object associated with this behavior touches something else. Okay, we get some collision data through that we can use to figure out what it's touching and all that, but that's not important here. So we want to go now and get component, and we'll look for the first audio source component on this game object that this behavior is associated with. So bring back that first one, and we'll play whatever sound it's got in it. Boom. Now, if we go play, and we do that, okay, and I do this every single time I do it. You need to actually put the script on the ball. The code's not going to execute if it's not in the game, right? So now we play, yeah, just like that. And you can hear it fall on the floor and roll around, right? Boom. Okay, so this is all well and cool, but it's bloody ugly. Okay, so let's bring in some images and some graphics. So a ball is just kind of this flat thing. So we really want to put in a little logo on our ball. So to do that, we're going to look over here in our mesh renderer. And the mesh renderer is the part that actually renders it. So in this case, it's using a sphere mesh. Over there. So it's using that sphere mesh over there to render it, and it's got some stuff there that I'm not going to go into. You can tell whether shadows should come onto it and so on. But the important part here is this materials. I want to put a different material on it because that is what makes up the skin of your mesh, so what it gets wrapped in. So I'm going to create a new material for it. We go create material, and I'm going to call that my ball material. Okay, a material is a combination of a shader and all of the things that that shader needs to do its job. A shader is a piece of very low level, very hard to write code that tells the DirectX chain how to render each pixel. So it gets information about light that hits the pixel, things like normal maps and stuff, and then it says, okay, so given all these parameters, make the pixel this color, and do that for every pixel. So that's a really, really quick way to tank your application's frame rate, is if you try and write your own shaders. Don't do that unless you know what you're doing. So we've got our ball material. We're using a standard shader from Unity, and we are going to take this image over here. This is just a standard PNG. If I double-click it, it'll open up over here. And we're going to take this image and assign it to the albedo map for the shader. Okay, now you can do other things like normal maps and height maps. A normal map is a flat file that indicates the texture of it, so the 3D texture. And that's how you do things like simulate hair or riffles or texture on wood. And so the shader uses that with the light that comes in, calculates the tangent of it to figure out how to refract the light, how to diffuse the light. So you get that 3D feeling without having to deal with the polygons. It doesn't introduce extra polygons into your app. Okay, so we've got our image over there. I'm going to also make it to emit just a little bit of light. Come on. And we're going to use about there, close, and I'm just going to set smoothness there and use the albedo alpha to control that. And so that's what our material looks like now, okay? So anything that we wrap with that material will kind of have that logo and that feel. So let's go wrap our ball with it. So we go back over here, we find our mesh renderer, and we drag our ball material onto the material over there. And now our ball has a logo on it. Yeah, that's pretty cool. So we've got the NDC Sydney logo on there. Now our paddle. Our paddle needs wood. Paddles should always be made of wood. Plastic paddles are not good. So to do that, we want to do the same thing. We want to put in a material. But that's where I talked about the asset store before. I don't know how to make wood. I'm not a wood maker. So I can go to the asset store and I can go buy some wood. Or in my case, download the free wood. So I search for planks, hit enter. I'm a cheapskate, so give me only the free ones. And there's a bucket load of wood available in the asset store. So this is the one that I used. I click on it, and they've got some wood over there, 5 high-quality plank textures with 18 variations. This looks good, so you click the import button, it'll go download that package, open it up, decompress it, and copy the contents of it in here. Now, if I have a look over here, these plank textures I've deleted some of them just to make things faster. But these are the plank textures that I want to use. So I've got a few options over there. If I click it, that's a material. Okay, so that's got a shader, and they've assigned normal maps and height maps, and that's how that plank actually looks like it's got texture on it. It's not just a flat image. So let's go back to my paddle. So the paddle, we go over here into our material. We search for planks 1, and I'll use that color over there. That's a beautiful color to me. And we'll do the same thing for the handle. Planks, again, double click it. And now we have wood. All right, how cool is that? Just like that. Handle and paddle. It's not good enough though, right? Every paddle needs a decal on it. So the last thing I want to do is show you this guy over here. I've got another image on here called paddle decal. Again, it's a regular PNG. It looks like that. I'm going to change this one into a sprite. We'll use a 2D sprite, and I'm going to apply my settings and drag it onto my paddle. Like that. Okay, so that's not really what we want. We don't want it to be big like that. So we'll set it to 1, 1, 1, and we'll set it to 0, 0, 0, and now it's kind of weird, right? But it's a child of that paddle now. But what's happening here is that its rotation is wrong. So we need to rotate it along the x-axis again, same as our paddle. Right, that's much better. Look at it from the top. And now we want it to be just above our paddle. So we set it to 1.01. Okay? And not the z-axis because we've rotated it again, but there. Okay, cool. There we go. So now it's just above our paddle, but it's a little bit big. So we're just going to shrink this guy down like that. Cool. So now if we hit play, we'll see our lovely ball over here, and we see our paddle with our decal over there. One last thing that I want to do is instead of actually ball behavior, no, not ball behavior, paddle behavior. Instead of returning the ball back to its origin, I want to create a clone of our ball so that we've got a new ball every time to play with. So we'll go ahead and we'll delete this stuff. Okay. And we will go ball equals instantiate from the ball, so create a clone of the ball at this location. We assign it to our ball object, and we use gravity on it as false, so it'll just kind of stay where we left it. Okay, now, file, build settings, go through this rigmarole again, click build. Same folder. So what happens when you do these builds is we won't overwrite all the files in there. It'll only overwrite what's changed. And if you go have a look in that directory, there's actually a file there called unityoverrides.txt. And you can use that file to control when and how these files should be overwritten. So if you've added things to that output project, you can keep them from being overwritten. They'll stay there. Make sure you check them into source control, because occasionally someone do mess up and the files get lost. So you want to keep them in there. But it's important that this directory doesn't get completely recreated every single time. So it saves you a lot of time on like plugins that you've added in and all that kind of stuff. So we're packaging up these assets. This is taking longer than I like. Okay, switch this one back on. We're almost done. Yeah, still connected. Okay. Okay, so we've created our solution. We'll just open up this one again. Sorry, the other one again. And go reload solution. And we'll hit play to our device. Now, if we have a look over there, show it to us now because we're already building. Hopefully this works. Sometimes this fails and there's a checkbox that you have to check to uninstall and reinstall the app when you deploy it. So otherwise it'll just deploy changes to it. But this morning I've been having trouble with that. Okay, so pushing our app through. Is this still connected? Yeah. Deploy succeeded. Okay, so let's switch over to our live stream again. Our app is starting up. There's our splash screen again. Here's our paddle and our ball, so we can see now there's a nice little texture on there, NDC Sydney. I forgot to switch off the visual meshes, so it's still here. You can switch off these visual meshes just with that one button, and it'll still be aware of the environment. But see, it's mapped the table, and it's mapped the lectern. And now, if we go that, and it goes off to the side over there. See how they kind of, okay. Yeah. Now, see how it only kind of maps to there? So if you move around, it kind of adds to the map of the room. Let's try and do that. And after a moment, it'll kind of become a bigger room. See how it becomes bigger? And now if I come back over here, it'll stay the way that it is over there. So, yeah. Okay, cool. So that's basically our demo. There's a few more things that one would do. Okay, awesome. Entertaining. There's a few more things that you would do from here, like add a scoreboard and all that stuff. And I'm putting all of that in my tutorial series that I'm writing. So if you want to walk the journey with me, then have a look at my GitHub repo. So I'll stop this one here. Click stop there. Back to PowerPoint, because you always need to thank your audience. Thank you, audience. Here's my contact details. That's my Twitter handle over there and my email address. Please feel free to email me if you want to know any of this stuff, or hit me up on Twitter. I'll be around here for the rest of the day at the conference, so happy to chat about all of the stuff with you and where we're going with it.